Welcome 8th graders. Today we're going to be doing section 1.2, solving multi-step equations. If you haven't done so already, make sure your note sheet's up and you're following along with the notes. Our first thing we're going to do is a warm-up. So 2n plus 5 plus 3n. We're going to simplify this expression. And when I say simplify, I mean combine like terms. The first thing I'm going to do is I'm going to identify like terms. So, I want to highlight. So this 2n and this 3n, they both have n's in them. They're like terms. And then my other term I have is 5. That's just a constant or just a number. Now, in order to combine these like terms, I'm going to rearrange this expression so that like terms are next to each other. So I'm going to rearrange it by flipping the 5 and the 3n. So I get 2n plus 3n plus 5. Now I can do this flip because of the commutative property. 5 plus 3n is the same as 3n plus 5. Now the next thing I'm going to do is I'm going to combine 2n plus 3n. So 2n plus 3n, that's the same as thinking, okay, I have 2 n's and then I have 3 n's. So I have a total of how many n's? Well, I have 5 n's. And then I'm going to drop down that plus 5, giving me 5n plus 5. And that is my final answer. Now let's move on to our essential question. How can you solve a multi-step equation? How can you check the reasonableness of your solution? Right now, I'm going to have you write about any background knowledge you might have about this essential question. Maybe you can relate it to what we did yesterday. Maybe you know what a multi-step equation is. Whatever you know, tell me. So let's go over our key idea, solving multi-step equations. When we do this, we want to use inverse operations to isolate the variable. This is just like what we did yesterday. So we isolate the variable, or we just want to get the variable by itself on one side. Remember, when we say variable, we're talking about x, or in some cases it might be n or a different variable or letter. When we talk about inverse operations, we're talking about the inverse operation of addition is subtraction, and the inverse operation of multiplication is division. So in an equation, if we want to get rid of addition, we subtract. Or if we want to get rid of multiplication, we divide. Now, let's do a couple problems together to kind of illustrate that key idea. So solve the equation, check your solution. So let's start out with negative 3z plus 1 equals 7. Well, I notice right here I have a negative 3 times, right, that I need to get rid of, and a plus 1 that I need to get rid of to get z, our variable, by itself. Well, which one do I get rid of first? Let's see. I like to use the best friend method for figuring out which one I need to get rid of first. So the best friend of z is the one that is closest to z. It's the one we want to get rid of last, because best friends, we want them to stick together until the very end, until the best friend absolutely has to go to isolate the variable. Negative 3 is the best friend because it is the closest to z. And then our plus 1, that's the other thing we need to get rid of. He's not the best friend, so we're going to get rid of him first. Now I'm going to make my t-chart and start isolating z. So again, we said we're going to get rid of that plus 1 first. To get rid of a plus 1, we subtract 1. And remember, on equations, you do things on both sides. Make sure you are setting it up with the t-chart method, because that just really helps you keep organized and make sure you are doing things to both sides. So when I subtract 1 from the left, I'm just left with that negative 3z. And when I subtract 1 from the right, I'm left with 6. Now I just need to get rid of that negative 3. Remember, that's a negative 3 times z. So to get rid of it, I'm going to divide by negative 3 on each side. And then I'm left with z equals, 6 divided by negative 3 is negative 2. Now, remember, it does say check your solution. So how we check the solution is we take our answer and we plug it back into z to make sure we get the same to make sure that the equation is true. Then we know it's correct. This is an important step because then it catches if you made any mistakes in your equation solving process. So I'm going to rewrite -3, and then I'm going to plug in that -2 for z, because that's what z equals, plus 1, and that should be 7. So let's simplify this, make sure it equals 7. So -3 times -2, that's a positive 6, excuse me, plus 1. 6 plus 1 is 7. These two match. Good, it's correct. Okay, let's move on to number 2. 1/2 x minus 9 equals -25. What is the best friend to x? It's going to be 1/2. It's the thing that's closest to x, the thing we want to get rid of last. So we are going to start, we're going to make our t-chart. And since 1/2 is the best friend, we're going to get rid of that -9 first. How do we get rid of that -9? If you said add 9, you are exactly right. I'm going to add 9 to each side. So when I add 9 to the left, I'm left with 1/2 x. When I add 9 to the right, I'm left with -16. Now, it's time to get rid of that best friend, that 1/2. How do I get rid of 1/2 times? I can do two things. I can divide by 1/2. I can also multiply by 2. I'm going to multiply by 2 because I like it a little bit more. But you can do whatever you want. So when I multiply by 2 on the left, I'm just left with x. When I multiply by 2 on the right, I'm just left with -32 as my answer. Am I done yet? If you said no, you're exactly right. I need to check my solution. So I'm going to take that -32 and I plug it back into that equation. So 1/2 times, x, which is -32, minus 9, and that should equal -25. Well, 1/2 times -32, that's -16. Then minus 9, -16 minus 9, that's -25. And that is correct. And let's do another example. Solve 8x minus 6x minus 25 equals -35. Now, if you notice, there's 3 different things on the left side instead of 2. So what we're going to do is we're going to look at it and see if we can simplify it before we start solving it. Now, you might notice this is similar to our warm-up. There are 2 terms that have x's in it, and just one term that's just a plain number. So we can combine those like terms, the 8x and the minus 6x, before we start solving the equation. So 8x minus 6x, that is 2x. Whoopsie. Now, there's multiple ways to know that 8x minus 6x is 2x. One way is you can use the distributive property and rewrite 8x minus 6x as 8 minus 6 times x. And again, you can distribute that x into verify that it equals this thing right here. I'm now going to drop down that minus 25, and that equals -35. I'm going to make my t-chart, and I'm going to solve. Who is my best friend for x? If you said 2, you're exactly right. I'm going to get rid of 2 at the very end. So I'm going to start by adding 25 to each side. To get rid of that minus 25, I add 25. That's an inverse operation. So on my left side, I'm left with just 2x. On my right side, well, -35 plus 25 is -10. And let's see, now I need to get rid of my best friend, so that's a 2 times x. To get rid of that 2 times, I will divide by 2. So I'm left with x on my left side, and -10 divided by 2 is -5 on my right side. So x equals -5 is my answer. I can check my solution by plugging -5 back all the way in the original. So 8 times -5 minus 6 times -5 minus 25. Well, we're hoping that's -35, and we're hoping we didn't make a mistake. So 8 times negative 5 is negative 40, minus 6 times negative 5 is negative 30, minus 25. So let's see, that's negative 40. Well, minus a negative is the same as plus 30 minus 25. So negative 40 plus 30 is negative 10. Drop down the minus 25. And negative 10 minus 25 is minus 35. And that equals what I wanted it to equal. So we are good. Okay, let's end this video with an word problem. So, use the table to find the number of miles X you need to run on Friday so that the mean number of miles run per day is 1.5. Well, the question that I need to answer is I need to find the number of miles X I need to run on Friday. Now, what is my key information? Let's see, I want the mean number of miles run per day to be 1.5. That is important. Let's see, the number of miles I ran on Monday is important. Number of miles I ran on Tuesday is important. Number on Wednesday is important. Number on Thursday is important. And number on Fridays is important. Let's see. And the fact that my answer should be in miles is also important. And that it's what's on Friday is important. And that is also kind of summed up right down here. Now again, I want the mean to be 1.5. So I'm just going to write mean equals 1.5. That's what I want for the week. Now, what is the mean? Remember, the mean is when you add up all the values and then you divide by how many values there were. So in this case, the mean is the number of miles on each of the days. So on Monday, I ran 2. On Tuesday, I ran 0. On Wednesday, I ran 1.5. On Thursday, I ran 0. And on Friday is unknown. We don't know it. They're telling us right now that it is X miles. That's what we're trying to figure out. How many miles X I need to run. So I have a certain mean. So I'm adding up 5 total values. And it's important that it's 5. That's why even though you might be like, well, why did you include 0 when you added them up? Because we know anything plus 0 is just what we started with. Well, it's important to keep the zeros in that addition thing so we remember that we're also including them when we divide by the total number of values. So make sure you divide by 5 because there's 5 different things, 5 days. So that's our mean, and we want that to equal 1.5. Now again, this might be looking a little bit complicated, but let's just see if we can simplify anything before we solve. Well, let's see. What I can do is I can simplify this 2 plus 0 plus 1.5 plus 0, right? Well, 2 plus 0 is 2, plus 1.5 is 3.5, plus 0 is 3.5. So I'm left with just 3.0. No, I don't want to highlight. I'm left with 3.5 plus x, right? Divided by 5 equals 1.5. Now I'm going to ask you, who do you think the best friend is to x? Now, if you said, now this one's a little bit trickier because it doesn't look like the ones that we did so far. If you said 3.5, you are exactly right. So, and why it's 3.5 is I kind of like to think that those two are the closest right here. They're kind of buddies right up here. And if you want to think about it, you can say, oh, well, we're dividing by 5 on both things, but just this 3.5 is extra close to the x right there. They're best friends. I sometimes also like to think of order of operations when I do this. If I actually had a value for x, what would I do to x first in order of operations? And it would be to add that 3.5. I wouldn't divide by 5 first. I would add that 3.5 first. You could also think of it as, whoopsie, when we have multiple things in the numerator of a fraction, they always come first. We can put those in parentheses if we wanted to. Now that we know that 3.5 is the best friend to x, we can start solving this equation. We want to get rid of that divided by 5 first. So how do we get rid of divided by 5? We're going to multiply by 5 in each side. When we multiply by 5 on the left, we're just left with 3.5 plus x. When we multiply by 5 on the right, we're just left with 7.5. Now I want to get rid of a plus 3.5, so I'm going to subtract 3.5. on each side. And on my left side, I'm just left with an x. On my right side, I have 7.5 minus 3.5, which is 4. So my answer is x equals 4. Now again, we can go back and we can check this. In our original equation, we can type in right here 2 plus 0 plus 1.5 plus 0 plus 4 divided by 5. It should be 1.5. Well, on the top, when I add all this together, let's see, I'm going to get 7.5, and then that's divided by 5. Whoops, you can't really see my 5 right there. We want that to be 1.5. Well, 7.5 divided by 5, that is 1.5, so that works out. Now remember, when we do word problems, we always have to write our final answer in a complete sentence. So 4 is what? Remember, 4 is the miles that we need to run on Friday. So you need to run 4 miles on Friday to get a mean of 1.5 miles this week. Okay, let's see. The next thing I'm going to have you do is I just have a couple of on your own problems I want you to do before our check-in on Thursday. We'll go over these problems and any questions you might have on our check-in on Thursday. Thank you.